What is the quality of service? Quality of service refers to the technology that manages data traffic to reduce packet loss. Yes, but which packet? Important packets. See, definitely there is going to be a loss when there is congestion. If you don't want loss, then increase the bandwidth. That is the best quality of service. But if I am not ready to increase my bandwidth, and if I say I will make sure there will be no packet loss, it's a lie. See, that's why it is saying here, reduce packet loss. It's not zero packet loss. It reduces packet loss. How? How it reduces packet loss? For that, there is a method. What? Weighted fair queue. So you give weightage to the different type of traffic. Depending on the weightage, the prioritization is done. So if you know a packet will time out very fast, then give more weightage to that so that will not get lost. Give more weightage to those time sensitive traffics. In that way, you can reduce packet loss. You cannot avoid packet loss. You can say if there is congestion, you can drop all this packet, no problem, but don't drop these packets. So QoS is to reduce the packet loss, not to avoid packet loss. You're going to say which packet to drop when there is congestion instead of router dropping some traffic. When router drops, sometimes it will drop the important traffics. But when you configure to drop less important traffics, then you can protect, you can save, you can avoid important packet getting dropped. That is what here it means. Technology that manages data traffic to reduce packet loss. Not only that, latency. See, as I told you, voice traffics are time sensitive traffics. They need to be delivered on time. There cannot be latency, there cannot be delay. So by putting the voice traffic in a high priority queue, there is a method called PQ, priority queuing. We are going to discuss on those things, weighted fair queue, priority queue. Now, when you put those voice traffic in the priority queuing, whatever happens, that priority queue will never slow down or drop any traffic. That is priority queue. So by doing so, you can reduce the latency. Now next is jitter. What is jitter? You know what is latency? Latency is nothing but delay. What is jitter, you know? Okay. Jitter is also a kind of delay, but it is not steady. It's not steady always. Sometimes it is more delay, sometimes it is less delay, sometimes there is no delay. Variation in the delay is dangerous. See, if there is a constant delay, you can correct it easily. But when there is a variation in delay time to time, very difficult to correct. Do you agree? Yeah, that is what called as jitter. Variation in delay. So now, how do you avoid that variation in delay When you mix all type of traffic together, only then that variation and delay happens. When there is when the other traffics are in peak, then variation is too much. When the other packets are moderate, then variation is normal. So jitter is up and down and up in the delay. Differences in delay is jitter. So quality of service is a technology which we enable on devices in order to reduce the packet loss, latency, jitter. Quality of service controls and manages network resources by setting priority for specific type of data and network, which you already understood. Enterprises network needs to provide predictable. What is predictable? Meaning not jitter. Jitter is not predictable. It keeps changing, right? Jitter is changing delay. That's not predictable. See, if there is a predictable delay, then you can correct it easily. Enterprises network needs a predictable delay and measurable service as an application such as voice. As I told you on the other class, the voice packet cannot be delayed more than how many milliseconds? 300. 300 milliseconds. That is the predictable, that is the delay that is allowed. All right, delay sensitive traffics, videos, UDP traffics. Organization uses quality of service to meet the traffic requirement of sensitive applications such as real-time voice, video, and to prevent degradation of quality caused by packet loss, delay, and jitter. Organization can reach quality of service by using certain tools and techniques such as a jitter buffer, traffic shaping. We are going to see this. Jitter buffer, meaning what? When you have a buffer where the traffic can come, reside, get arranged, and sent, then you can reduce the jitter. Traffic shaping is what? Traffic shaping is when a high priority traffic is using a queue, and if the queue is full, the packet will get dropped. To avoid dropping, what we do, before the queue gets full, you delay. You delay the traffic so that queue will never get full and traffic will not get dropped. That is what traffic shaping. You see, when we board the flight, they send a few people and then they stop. They say, please hold on for a second. Why? If everyone goes, then very difficult for the people to keep the luggage on the overbin and take their seat. It takes time. If you send few members, customers, they can easily get settled inside the flight. If everyone goes at the same time, oh, difficult. All wants to use the overbin at the same time, and all wants to find their seat at the same time. Difficult. So you need to shape the traffic. How you shape the traffic? You call the last 10 row people first. Let them get settled, and then call the next 10 row, and then the remaining. This is traffic shaping. You avoid delay by traffic shaping. If you would have allowed everyone at the same time, people in the front few seats will be occupying the path because they need to put the baggage on the overbin. They need to find the seat, um, etc. things. And then they block the path. The people at the back who are supposed to go to the back will be getting trouble. They won't like waiting for a long time. They will lose their patience. So to avoid all this, they do traffic shaping. Same thing in the networking. Listen carefully. I'm coming to the main part. Same thing in the networking. If you are allowed to send only 100 meg packet to the ISP, you have subscribed for how many meg? 100 meg. When you have subscribed for 100 meg, if your network is trying to send 200 meg, what will happen, No. On ISP side, they won't maintain buffer for every customer. Well, they will simply drop your traffic only to the 100 meg which you have subscribed. They will accept the traffic. The balance 100 meg, they will drop it. And because they are dropping, your devices will keep on resending it. So inside your network, the bandwidth gets increased, CPU gets increased, the devices get busy, and network goes slow. Because they need to resend again, because the ISP is dropping again. What is the best solution? Don't send too much. Send it within the limit. What is the limit? 100 meg. When you have subscribed 100 meg, make sure you don't send more than that. That solves the problem. That is what traffic shaping. You shape it. Don't simply send too much thinking that, I paid for 100 meg and I'm making my ISP to work for me for 200 meg. And that never works. That never works with ISP. ISP need to support many customers. So they want to make sure you don't take more than what you're supposed to, because they are answerable to other customers also. So traffic shaping is a very nice, important technique. Jitter prefer is queuing. There is also an important technique. Now, for many organizations, QoS is included in SLA with their network security provider to guarantee a certain level of network performance. That is what they are trying to say. Service provider will take care of QoS. That's what they're trying to say. Now, class of service is something used interchangeable with QoS. I told you, CoS class of service is what? Layer 2 or layer 3? Yeah. Class of service does not specifically guarantee the level of service in terms of bandwidth. It's an approach, it approaches traffic control from a less granular perspective. In many cases, whether someone refers to CoS or QoS, they are likely talking about the same concept. Okay, they're not that going deep. Let's go to the next one. QoS parameters, you know what is packet loss. I don't want to talk much on that. You know what is jitter, you know what is bandwidth, you know what is latency. Mean option score. What is mean option score? This is a metric to rate voice quality that uses a 5-point scale with 5 indicating the high quality. Okay. 5-point scale is what called as mean option score. It may come later. Let's see. Why is QoS important? This story we know very well. How does QoS works? This also we know very well. Let's see what this guy say. When an organization uses the network for sending back and forth between end-to-end information about the no. QoS tools takes no responsibility of prioritizing packets to get the most out of the finite amount of bandwidth on the network. In other words, the network can only transport so much information in certain amount of time. QoS tool prioritize packet in a way that ensures the bandwidth is used to provide best internet service possible in the fixed amount of time. Command is all not that valuable stories. Benefits of QoS. The main benefits of QoS is that it ensures the availability of organization network, whatever. We know what it is. So most specific benefit includes mission critical application have access to the resource they require. Yes. So what do? We match the mission critical applications and we set priority. We mark it high level of priority. Administrator can manage traffic better. Organization can reduce the cost by eliminating the need of purchase a new network infrastructure. Meaning, when we do proper quality of service, we can have enough of resources. So you no need to buy again another one. But when you don't have quality of service, then you may see like the network going slow, then you may need to buy some extra bandwidth, more bandwidth cables, more devices, something like that. So to an extent, quality of service can reduce the purchase. But according to me, the best solution is buy more bandwidth. You won't need quality of service. Again, I told you earlier, quality of service, whatever that you configure, will be effective only when the congestion begins. So user experience will get improved by quality of service. Implementing quality of service, planning, designing, testing, deployment, monitoring, analysis. Best effort delivery. Okay, this also we have spoken. You remember three type of quality of service. FIFO, that is what best effort delivery. There is no quality of service. First in, first out. That is best effort. Next is insert. Insert is end to end. End to end. You remember RSVP I told you. Recommended is diffserve. Let's see what these guys are telling about insert. Quality of service model that reserves bandwidth along the specific path. Yeah, that is what end to end. Whereas diffserve is quality of service where the network elements such as routers, switches are configured to service multiple class of traffic with different priorities. So each router, each switch can have different priority for the same traffic, which is possible. Hop by hop, you can decide what sort of treatment that you are going to give. This is MPLS traffic engineering, which is for INSER exam. QoS mechanisms. This is what I'm interested in today's class. This is a new portion which we have not covered earlier. Again, this is not totally new to you, a little bit of new to you. Like if you see the first point, classification and marking, you know already. Classification, you remember, we matched an access list. And then we matched the traffic that are marked with some IP precedence value. Do you remember that? So that is what classification. We use the class map. And also we marked the traffic. In the policy map, after that the traffic got recognized, we were doing some marking on the routers and switches. I was using COS value for marking first. Later I was using IP precedence value. Likewise, I can also use DSCP. In another example, when we do the lab, I'll use DSCP for you. Now, next is congestion management. See, we are learning QoS mechanisms. In that, the topic was classification and marking. Now, we are trying to understand how we can manage congestion, meaning what are the techniques, what are the tools with which I can manage congestion. These tools use packet classification and marking. See, you already classified, you marked. Now, based on the marking, the packet will be placed in a queue. You see, read the line again. This tool, congestion management tool, use the packet classification and marking to determine which queue to place the packet. See, if the packet is marked with 5, it will be going in one queue. If the packet is marked with 4, it goes in another queue. And the queue size you determine. Q1 for COS 5 will have 50% of the bandwidth. Q2 will have 10% of the bandwidth. You see? So, depending on your environmental requirement, you decide the queue. So, congestion management. These tools used packet classification and marking to determine which queue to place the packet in. Congestion management tools include priority queuing. This is a very fast queue. Congestion management, one of the tool is priority queue. What is it? It's a queue that will never stop forwarding traffic. Whatever you place in this queue will never be delayed. But the other queues are not like that. Depending on the weightage, the queue delay will vary. But priority queue is the high, that is why it is called as priority queuing. PQ. PQ is a method of queuing where anything goes inside the queue will never be stopped. First in, first out queuing, that is best effort delivery. First in, first out queuing is nothing but what? Hardware queue. Whichever goes inside the hardware queue first will come out first. Low latency queuing, that is another method. To reduce the latency, based on the weightage, the traffic with heavy weightage will be sent first, followed by the next high weightage traffic, so that you can avoid latencies. Okay? There is low latency queuing. Where am I? Oh no. Here it is. There is congestion management. Please understand, to avoid congestion, to manage congestion. It is not avoidance, to manage. To manage congestion, I may use priority queuing method or the first in, first out hardware queuing method, and then low latency queuing. Congestion avoidance. What is the purpose of this one? This is to avoid the congestion. Please understand the difference. Managing the congestion is one, avoiding the congestion is another. Here, Drop low priority packets is one method of avoiding congestion. You understand? What did you understand? Ah. So when there is a congestion, yeah, so that the high priority traffics will never get dropped. Dropping low priority packets when congestion occurs is one of the congestion avoidance. Can you give any real world example? You don't know any example? Real world example. Okay. All right. Now, congestion avoidance tools include weighted random early detection. This is another tool to avoid congestion. You see, based on the weightage, see the word weighted, based on the weightage, before the congestion happens, you predict that there is going to be a congestion, and before the congestion, that's why they say early. Early means what? Before you start dropping randomly. The packet with less weightage will be dropped. This is not after congestion. This is even before congestion. That is why it is called as weighted random early detection. So early you detect that there is going to be a congestion, and you see the packets with different weightage, and you drop the packet with low weightage. We did one exercise. AF11 will be dropped when there are more AF43. You remember? AF11, AF43, AF21, AF31. Yeah. That is what this one is. Weighted random early detection. Another one is random early detection. No weightage. It will even drop some important fact. Please understand. Weighted random early detection is better than random early detection. Random early detection is randomly dropping any packet when there is going to be a condition. Weighted random early detection is when you are detecting a congestion going to happen, you drop the less weightage packets. Less weightage packets. So when I was waiting in Shanghai for 3 days in airport, 3 days for my flight, 3 days. Why? Because I was in an economy class. The first class and business class people of my same flight got chance on the very next day to fly in 24 hours. But for economic class people, they did not give priority. There was some war between China and Hong Kong when I was trying to fly from Shanghai to India. So the flights were not allowed to fly, and I was waiting every hour without sleeping, without drinking, without eating for 3 days. Yeah, what if I just go to the go to take bath for some time, and they call my name. I lose my turn then. So it was very difficult. Always watching when they call my name. It was very bad experience. So that is what weighted random early detection. Based on the weightage, they dropped me because I'm not having much weightage. I'm just an economic class. So they didn't give me more weightage. Weightage was given first to the first class people and children and women's. For that itself, they took 24 hours to send them, and then afterwards business class, afterwards economic class. It took time. Anyway, that is where weighted random early deduction. Next is shaping. I told you already shaping what it is. Instead of going and getting dropped in the ISP gateway, you only can delay your packet and send it within that limit so that you won't get dropped there. Traffic shaping is, let me see what these people have written here. These tools manipulate traffic flow into network and prioritize real-time applications over less time-sensitive, such as email and messaging. Traffic shaping tools include buffers. Yes. You see, that is what I was telling. When you are supposed to send only 100 meg, you send only 100 meg. But you want to send 200 meg. What you can do is send 100 meg and keep another 100 meg in the buffer. Keep it with you. Don't send it out and get dropped there. You may have 1 gig link between you and ISP, but don't try to use that 1 gig full, because the gateway inside is only open for 100 meg. Yeah, so traffic shaping. Link efficiency. The tool maximize the bandwidth use and whatever. That is different story. QoS tools. QoS tool classification, that is using class mark. Queuing, you put them in different buffer. That is what queuing. Like you reserve bandwidth. You remember we did one lab, 10% bandwidth, something like that. That is queues. You can create many reservations like that. You create queues. Policing. What is policing? ISP will do policing. Or give an example. What is policing in ISP? When I say ISP will do policing, what do I mean? You are supposed to send only 100 meg. So they keep an eye. They keep a check. If you are sending more than 100 meg, what they do? That is what called as policing. Now you read the line. Enforce a specific bandwidth and limit as well as drop packets that does not adhere to the rules. What is the rule? 100 meg. If it is not within that rule, what is going to happen? Drop. This is one of the congestion avoidance. Do you agree? How it avoids congestion? Because they limit for you 100 meg, the other customers will not face problem. If they allow you extra, what will happen? They have to allow you from someone's bandwidth, and they will complain. So policing is nothing but checking whether the traffic is within that limit. If it crosses more than the limit, if it goes more than the limit, then drop is the policy by policing. Policy is to drop. Policing, it will not show mercy. Policing will not show grace. Policing will not show sympathy. Shaping is showing some flexibility. Shaping is when the traffic exceeds, instead of dropping, what do? You put it in the buffer so that it can be delayed. You just delay and send. That is shaping. Tell me who will do shaping and who will do policing with your understanding that you got. The customer. The customer before you send to the ISP. Customer before sending to ISP, they should do shaping. Otherwise, your packet will get policed by ISP. So on customer side shaping, service provider side policing. Next tool is weighted random early discard. W red. We used to call it as red. Red means random early detection. This is weighted red. See, drop low priority traffic when congestion happens. Yes. Next, fragmentation and compression. So, cutting down the large size packet into small fragments will also make the delay low, jitter low. If you have big packet, it takes. Look here, listen. That is what job of the interface on the router. You see, router according to the capacity of the link, the TCP layer means transport layer will fragment it. No, this is automatic. This is automatic. See, lower bandwidth on the network to prevent delay and jitter. Lowers the bandwidth on the because you make it a small piece. Bandwidth utilization will be low. In that way, you can easily move. When the packet is too big, it is very difficult to move easily. When the packet is fragmented, compressed, it becomes tiny, and it can easily move through the network, which avoids jitter and delay. Okay, so that's all. These are all different vendor tools, which is not our area of study. Good. It was almost covering all of it. But now I need to take you to some Cisco, whatever we covered earlier, or more of practical oriented uh, weightage, COS, DSP. See, they did not mention any of that here. Those are the marking techniques. And we did one queuing lab. We matched the ICMP, we marked the packet. Now, what if I want to have multiple queues? For that, we need to go to another